has started.
So for the first one here, remember the steps we take, we have to combine anything we can combine on either side. Number one, there's nothing to combine on either side. Step two is to make sure the variable is on only one side. Well, here it's on both sides, so we have to get rid of one of them. The 6x is the smaller one, so I'm going to get rid of that. It's positive, so I'm going to subtract 6x. 8x minus 6x is 2x. Still have a negative 3 there. On the right side, the 6x is gone. And we have just a positive 9. Now we're at that form where we can add 3. 2x equals 12. And then divide by 2. X equals 6. Number 2, we do have some combining to do on either side. So let's start on the left side and combine what we can there. Got the parentheses, nothing to do inside the parentheses. We're going to multiply by the 3. 3 times 4x is 12x. 3 times negative 7 is negative 21. Then we still have the negative 2x there. So there's still more we can combine there, so let's keep combining. 12x and negative 2x. Take 10x. And we still have the negative 21. So that's all we can combine on the left side. Go over on the right side. First set of parentheses, nothing to do in there, so we're going to multiply by the 5. 5 times 2x is 10x. 5 times 1 is 5. The second set of parentheses is being multiplied by a negative 2. Excuse me. Negative 2 times 3x is a negative 6x. Negative 2 times negative 2 is a positive 4. We'll go ahead and combine what we can still combine. 10x and negative 6x make 4x. 5 and 4 make 9. So, excuse me. We've combined what we can combine on either side. We still have a variable on both sides, so we have to get rid of one. Subtract the 4x from both sides. So on 10x minus 4x is 6x. Still have the minus 21 there. Equals, here the 4x is gone, we just have the 9. Now we're ready to solve. We add 21 to both sides. 6x equals 30. We divide by 6. X equals 5. I'm going to give you a couple others to try here. Give those two a shot. So for the first one, first thing we have to do is to get rid of that dividing by 2. We look at what was done to x here to build this. X was multiplied by 3, 7 was subtracted from it, and then the whole thing was divided by 2. So to take it apart, we multiply by 2 to get rid of the dividing by 2. So we've got 3x minus 7 equals 7 times 2 is 14. Then we've got, we're going to add 7. Get 3x equals 21. And then we'll divide by 3. X equals 7. Second one. Well, we're going to start out by adding the 2 1/4. One and a half x equals 5 1/4. Or sorry, 1/2 x equals 5 1/4. Divide by 1/2. X equals 10 1/2. Any questions there? Well, our next step is to look at equations that are like this. No numbers in them, all variables, all symbols. AX plus B equals C. Now, because technically every part of this equation is a variable, I have to tell you what variable we are trying to solve it for. So if I say solve it for X, well, we're going to solve this just like any other equation. X here has been multiplied by A, and then B was added to it. So we're going to subtract B. So that B is gone. The only difference is on the right side, B and C are not numbers, so I can't combine them like I have been. C minus B is just going to have to be left as C minus B. And then I do still have to divide by A to get rid of the A. So that gets X by itself. C minus B divided by A is just going to be left as that fraction, C minus B all over A. A lot of our formulas that we use in machining need to be rearranged to make them more useful for us. Like this one here, this is the surface cutting speed formula for turning. Where N, of course, is your RPMs. Well, often we don't want to just set the RPMs and then calculate what the surface cutting speed is going to be. We want to know what RPM is needed to give us a desired surface cutting speed. So we would want to solve this for N. Well, first thing I would do, I'd multiply by the 12. So 12F equals pi times D times N. And then the pi and the D are both multiplying N. So to get rid of them, I'm going to divide by pi and D. So I have 12F over pi times diameter equals my number of RPMs. Yeah, that one ain't going to work for us today. Let's just do another one here. Let's do this one. mx plus b equals dx minus c. I'm going to solve for x again. Now here we see that x appears twice. So just like we have with any of our other stuff, we got to get x on the one side of the equation. I'm going to have to take one away. Now it doesn't matter which one, we don't know which one's larger, mx or dx. So I'm going to get rid of the dx. Now here's the tricky part. mx minus dx is just m minus d times x. On the right side, we've got the negative c over there yet. Well, now to try to get x by itself, we're going to subtract the b. We've got the m minus d times x equals a negative c minus b. Then we have to divide by the m minus d. X equals negative c minus b over m minus d. Like I said, in machining, there are a lot of formulas that the standard form of the formula is not the most useful arrangement of the formula. So being able to move things around like this is very useful for us. That's as far as I'm going to make it today, I think. The homework out of the big book. Page 455 to 457. Exercise 15-3. Seven through 35, the odd. And there is also a quiz out there for you. Which is due by noon tomorrow. So I'll let you guys have the last 25 minutes here to get 24 minutes to get started on work if you'd like.